We want to determine each of the following. So here we've got part A, which gives us the integral of x to the 5 minus 6x. Well, we should know that the integral of ax to the n dx is ax to the n plus 1, so we increase the power, divide by the new power, and then don't forget the constant. So here this is going to be x to the 6 divided by 6 minus 6x. Now remember, this x is to the power 1, so increasing the power goes to 2, divide by the new power, and add a constant, and then tidy up. X to the 6 over 6, take away 3x squared, plus a constant. So the next integral we want is 9x squared 1 plus x cubed all cubed dx. Now if you look at the inside function just here, if you were to differentiate that, you would get 3x squared. So if we rewrite this 9x squared here as 3 times the integral of 3x squared 1 plus x cubed all cubed, then we have something that is exactly of the form the integral of f dashed x, f of x to the n dx. And when we have something like that, it always integrates to f of x to the n plus 1 over n plus 1, plus of course a constant. So our integral is going to be 3, which is this 3 just here, 1 plus x cubed to the power 4 divided by 4 plus a constant. When we come over to look at this one, this is a fairly standard one. We know that when we differentiate tan x, we get 1 over cos squared x. We're going the other way, we're integrating. So therefore, this 3 is just a multiplier. Then we'll get tan 2x, because the argument doesn't change when we do this. But then, since we can differentiate the inside of this and get a constant, we need to divide by that constant. Think about using the chain rule for differentiation. You multiply by that constant. Now this only works when the inside function is a constant, but that will be the answer. Okay, so with this one here, it's a fundamental theorem question. If we have a function of x here, such as 2x, then let u be equal to 2x. Then we have d du integral, it doesn't matter if that's a constant what it is on the bottom there, and that's going to be u, and then that's t squared minus 1 dt. But to have this as d du, using the chain rule, we have to have du dx here. So du dx is 2, and then because of the reverse relationship between differentiation and integration, this will just be u squared take away 1. But of course u is 2x, so it's going to be twice 2x squared take 1, which is twice 4x squared minus 1.